Assalamualaikum warahmatullahi wabarakatuh. So, today our group gonna present Hooke's Law calculator, which is for our MATLAB project assignment. My name is ZIKRI ROSLI and my matric number is 205977. And my group member will introduce themselves later. So, we will proceed to introduction. MATLAB is an acronym that stands for Matrix Laboratory. And MATLAB was created to make it simple to use matrix software produced by the Linear System Package and Eigen System Package Soft Program. MATLAB is a high-performance programming language used in technical computing. The main purpose of the project is to minimize human error when computing a spring constant or force using Hooke's law and elastic potential energy to ensuring that the results obtained are correct. In this project, our Hooke's law calculator also generated graph plotting automatically.
Assalamualaikum. My name is NASRULHaq bin RUDZI. My matrix number 205919. So I will continue the presentation. So about the project background. Okay, this project had to determine the value of spring constant and the value of force that apply on spring, and last about the plotting the graph, the 2D graph of elastic properties of the spring. So the next is it also can assist the accurate calculation of Hooke's law equation, and able to plot the tree graph that assists to visualize the elastic properties of this car suspension, and the engineering application that relate to this project is help to the automotive engineer to realize the theory calculation of Hooke's law in engineering calculation. So the next part is about the example question. Okay, this question we find that need to calculate the force that need to of spring that to extend the length by 20 centimeters. So by this question, we can apply the Hooke's law formula, which is Fs equal to negative Ks. So we where the Fs is a spring force, K is spring constant, and the S spring surge or displacement. So just sub the data into the equation.
Assalamualaikum and good evening. My name is Adam with matrix number 205481, and I will talk about the program development. So this is the input, which is, first of all, we will let the input from the user for the menu, which is number 1 or number 2, which is the spring constant and the force. Then if the user choose number 1, menu number 1, we will let the input from the user, which is the force, the original length, and the extension length of the after force is applied. But if the user put number 2, we will want the user to put in the value of spring constant, the value of original length, and the volume of the extended length after the force is applied. Then after that, we will give the input to be added and to be calculated by using the formula force equal to K times extension, and then we will print the value of force by 2 decimal places. Then after that, we will input a calculation for the elastic potential energy, which is the formula 1/2 times K times extension squared, and then we will display the value of the elastic potential energy of the spring by 2 decimal point. This is the 2D plot, which is we have 2 graphs. First of all is the graph of force versus extension, and the line is in blue color. So the X level is extension, and the Y level is force, and the grid is on. And the subplot 312 is the second graph, which use elastic potential energy versus extension. So the X level is extension, and the Y level is elastic potential energy. So next is the program development for the 3D plot. So which is the subplot 313. So we will use 3 variables, which is the extension, force, and elastic potential energy. So each of these variable will have least space from 0 until the value of the user input by 100 data, 100 data. So we will plot extension 2, force 2, PE2 with the line of green. So the X label is extension with the unit M, Y label is force with the unit N, and the Z label is elastic potential energy, which I short it to elastic PE with a unit J, and the title will be Hooke's law and the grade will be on. So this is the result, which is the output after the user put the input. So which is we stated that this is the Hooke's law calculator without estimating the elastic limit. What choices the user want, which is spring constant 1 or force, which is 2. So the user put number 2. So what is the value of spring constant? The user put 5,000 Newton per meter. What is the original length? In the question they have the extension of 20 cm, so we will put 0, and the length after the load, which is the extension, which we will put 20. So after calculated by the MATLAB project, the value of force applied is 1,000 Newton. So then the MATLAB also calculate the elastic potential energy, which is the 100 joules. So this is the second result, which is the graph, which is the first graph is force versus extension. We have having a blue line, and the second graph is the elastic potential energy versus extension, which have the red dash line, and the last one is the Hooke's law graph, which is elastic potential energy against force against extension, which have the green line.
Okay, for the discussion part, we find that Hooke's law gives the relationship between the force applied to an unstressed spring cast suspension and the amount of the spring is being stressed. So the Hooke's law state the extension is proportional to the force. So the last part about the discussion, we find the terms of Hooke's law, that means when the spring will stretch, it will go back to its original length when the force are being removed. So that's about the discussion part. Thank you.
In conclusion, there are many important skills that we gain by applying MATLAB to this project, and the most critical of which is the capacity to distill an issue such that it may be handled using a computer method quickly and efficiently. Through MATLAB, we can essentially solve nearly any kind of mathematical problems simply by writing some programs, and also we can examine their graphs. In MATLAB, programs or codes are created for the specific problems along with the ability to carry out iterative solutions if required, and this programming script is extremely useful for us to solve an application issue that we face in our daily life. For example, by utilizing the MATLAB software, we may solve any problem regarding Hooke's law to determine force and spring constant and generate graph plotting. I think that's all from us. Thank you very much.